My name is Andrew.
And I'm Adrian to fetch.
And
Today, we're going to be talking to you about sound.
It's everywhere.
At home,
In school,
out here.
even in Miss Scheidler's room.
Today we'll be demonstrating how sound behaves in an open space.
For example,
From right here, you can probably hear me pretty well.
but if I move down here and speak at the same volume as I was up there, can you still hear me? You probably can because I didn't move that far away. But what happens if I move farther? If I move all the way back here and I'm still speaking at the same volume, my voice is probably sound stable.
He's saying,
Farther.
if I move back here and speak at the same volume, my voice probably sounds a bit farther. You may be able to hear it, but probably not. This is because sound is absorbed by air as distance increases.
I'm standing all the way back here. At the same volume. You probably can't hear me at all. Or if you can, it sounds very faint. That's because 80% sound is absorbed.
Andrew's talking right now. That was an example of sound.
This time it's different though because we're in a closed area.
Closed spaces, like theaters, absorb and reflect sound differently than open spaces.
For example, we are currently in the Chantilly High School Theater. Now, our voices echo here a bit more because one, we are in a closed area so the air will not absorb sound as much, and two, our walls here are made of concrete and are smooth surface. I will now talk to you about what happens when sound reflects off a smooth surface. When you're talking, or when sound reflects off a smooth surface, it reflects much better than it does on a jagged surface. And this is because smooth surfaces do not have any internal reflections and it will bounce straight off. For example, you probably can't hear it, but there are a lot of echoes right next to me.
Sound does not reflect well off of jagged surfaces. This is because sound has a great deal of internal reflections. Therefore, the sound doesn't come back out once it bounces off of a jagged surface.
I'm currently sitting in one of the seats at Chantilly High School's theater. Now, sound differentiates when you're sitting in a seat than it does on stage. This is because the seats are made of a fabric that will absorb sound a lot better than the concrete of the walls. So when you're sitting in a seat and you're trying to talk to someone on stage, you'll sound a lot quieter than the person speaking on stage.
Versus back here, where my voice echoes a lot, even though I'm projecting just the same as Andrew was. This is because I'm surrounded by concrete on the walls and on the floor, and there are no seats.
Now, when we were outside, we demonstrated how distance affects the volume of your voice and the absorption of the air. The same thing happens in the theater, although to a much greater extent. Because the fabric in the chairs absorbs much greater than the air, if you're sitting farther back, it's a lot harder to hear someone on stage. Adrian will demonstrate by reciting the Pledge of Allegiance on stage.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Adrian will now demonstrate what happens when he speaks in a closed area and how it differentiates from an open area.
Notice how, when I back up, you can still hear me, even though when Andrew backed up in the open area, his voice became more and more faint as his distance from the camera increased. Back here, you can probably still hear me really well. Probably even back here too, and I haven't changed the projection of my voice at all.